Okay, so now we're going to get into the concept of the mole. So Avogadro's number, Avogadro's number is 6.02 times 10 to the 23. So remember scientific notation, and since that's a positive number, we're moving over the decimal place 23 times to the right. So it's a very large number. And that's how many particles there are per mole. So why we use moles, it kind of helps us and scientists to make the numbers that they're dealing with a little easier in the calculations. Okay, so Avogadro's number, Na, and the mole are defined so that 1 mole of a substance with atomic, so AMU, or molecular mass, will have a mass of precisely 1 gram. Okay, so grams is also a lot easier to deal with than AMU. The mole is a basic unit of an amount. So if I said I had a pair of something, you would think 2 things. If I said a dozen, you would think 12. Now, if I say a mole, you're going to think 6.02 times 10 to the 23 of those things. So then the SI, so the mole is the basic unit of an amount. The SI unit for a mole, so for the units for moles, we use MOL. And the symbol is that we use the little n. And that's used to represent mole in calculations. The mass of 1 mole of a substance is called the molar mass. And the symbol mm is used, and the units are grams per 1 mole. When using the symbol mm in calculations, you must specify what you are calculating. Okay, so we're going to use subscripts for that. So for example, if I'm doing the molar mass of O2, that means the molar mass of oxygen molecules, so 2 oxygen molecules. If I say mm of Na, this means the molar mass of sodium atoms, so it's just 1 sodium atom. If I have the molar mass of water, or H2O, this means the molar mass of water molecules, and then the molar mass of NaCl means the molar mass of sodium chloride molecules. So then the difference between atomic mass and molar mass. So the mass of one atom of any element in atomic mass units, where molar mass is the mass in grams of 1 mole of atoms or molecules. Okay, so let's do some examples calculating. So I'm calculating the molar mass of iron, so I have to do mm and then little e. Okay, and you look at your periodic table for iron, and I have 55.845 grams per mole. Okay, and that's the molar mass, so that's that many grams per 1 mole. So now we want to do the molar mass of chlorine, so I'm doing mm of Cl2, so there's 2 chlorine molecules. So that means I have to take the mass and times it by 2. So 2 times 35.453. You gotta make sure you keep putting your units of grams per mole. Okay, so we're gonna multiply that. Okay, and then I get 70.906 grams per mole. Okay, let's try a bit of a harder one. So like the molar mass of water. So I get mm of H2O. So the first thing I need to do is I need to do 2 times the mass of hydrogen, because there's 2 hydrogens there. So I have my mass of hydrogen is 1.008, and we're adding the mass of oxygen. And since it's just 1 oxygen, I just have to put in 15.9999. Okay, oh, and I forgot my units, which is not good. There we go. Okay, so you're gonna first multiply this because you got to remember bed mass. So multiplication comes before addition. So I'm going to multiply this, and then I'm going to add them together. And I get 18.015. So my molar mass of H2O is 18.015 grams per mole. Okay, let's try Na3PO4. So the molar mass of sodium phosphate. So I go mm of Na3PO4. So I start with my sodium. I have 3 sodiums, so I'm going to do 3 times 22.990. And this grams per mole. Adding 1 phosphorus. Phosphorus is 30.974 grams per mole. Plus, and then I have 4 oxygens here, so I have 4 times 15.999 grams per mole. Okay, so again, do your multiplication first here and here, and then add them all together. And I get 163.94 grams per mole.